So we've got the bottles.
Yeah.
And we've got the scents.
We have.
What do we say?
Oh, a name.
Oh, a name.
That should have been step one, really.
Right, okay, you got one?
Got it.
Yeah.
Chanel number 6.
Oh, that's beautiful.
Yeah,
It's really
I thought
familiar.
of that myself, yeah.
Yeah. Oh, and 6 aromatics. It works in so many ways.
Yeah, well, 2.
Oh, that's enough.
Plenty,
Yeah, okay. So now we've got the bottles, the fragrance, the name. We just open, right?
But before we open the doors to this magnificent factory over there.
Oh yeah, it's a magnificent factory, yeah.
Before we open the doors, I think we should just check that we know everything, just so we don't have any embarrassment. If someone comes up to us and says, well, what's this reaction? We go, you know, they're going to laugh at us.
Let's not do
So
that.
let's make sure we know everything. This is applicable to you, actually.
Actually, the examiners like perfume, don't
They do, so if you know everything about everything, you'll do your exam. That's good.
That's good. Okay, so let's do that. So I know a bit about everything.
Yeah.
And I know that everything starts with benzene.
It does. We have a shed full of benzene for no reason.
We do, probably because Ben was here or something.
Oh yeah, something like that.
Yeah. Okay. So, yeah. That's benzene.
It is. You should know that. What can we do to benzene? What different reactions could we do?
Okay, we could halogenate it.
We could. So we can't add halogens just adding chlorine or adding bromine.
As you know, benzene doesn't decolorize bromine in water. It's not reactive enough.
But we can do a jazzy little thing so that we can add halogens in a slightly different mechanism, which we've done in a previous video.
Yeah, what we do is you add a halogen carrier. So it could be aluminium. That works. Also iron. Both of these things work.
I'm using the example of chlorine. If it was bromine or iodine or whatever halogens, you have 3 of them in just the same way, exactly the same. And we attach, one of them attaches to the benzene ring.
Yeah.
So that could be bromine, could be iodine, whatever.
Maybe making chlorobenzene, which is lovely.
It's lovely, love it.
Love it. So now we've got that. Not very helpful.
No, don't really need that.
So let's ignore that. What I want to do, I've got like a live goal.
Okay.
You know, there's cars that go really quick.
Yeah.
They use nitro, right?
Yeah, of course they do. Nitrous is
Yeah.
I've played Need for Speed.
Yeah. So I heard a thing called nitrobenzene. Is that the same?
Oh, I'm pretty sure.
Yeah, I reckon it is.
I'll put it in a car. Probably test it on someone else's first.
Yeah, that's a good idea. So if we want to make nitrobenzene, what do we need, Wayne?
Well, we're going to need H2SO4
Mm-hmm.
and we're going to need HNO3. But there's something special about both of these.
Oh yeah, I
this.
concentrated like my orange squash.
They are indeed concentrated. Like your orange squash. I'm just going to put C for concentrated.
Okay. Also, you have to have it quite toasty.
Yep. Almost like a toaster.
Yeah.
50 degrees Celsius is an approximation.
Yeah.
You could probably say 60 or 70 and it would be accepted. Hotter than that though, no colder.
Okay, so now it's quite toasty, we're going to make nitrobenzene. What does that look like? Well, we replace, say, the top hydrogen with an NO2.
Yeah. If you replaced any of the others, it's exactly the same thing rotated. So just as a general rule of thumb, draw it at the top, it looks neater.
Mm-hmm. Okay, so now I've got that. Don't want that either, Win.
You don't?
No, I want something else.
Well, you know what? There's that thing, it looks good. You know what I mean?
Oh, I do know what you mean.
Yeah, you know what I
we
mean.
can make an amine thing.
Good.
Okay, so to do that, we need to do something a bit different.
We do. We need to add HCl, another acid.
We do. This time it doesn't need to be concentrated.
It doesn't, but it does need a special catalyst.
It does, not just any run-of-the-mill catalyst.
No, it's tin.
Yeah,
Wouldn't have guessed that in a million years.
Tin, that's lovely, that is. And is this under reflux?
It is indeed under
Alright,
reflux.
so it's under reflux, which is, you know, pretty reflux-like.
It's pretty reflux-like. If it's going to be anything, that's what it's going to be.
Yeah.
So now instead of NO2, it's NH2, so an amine. Just like that. That's lovely. But I don't want an amine.
No, you don't?
No.
No. I thought I knew what you meant, but I don't.
A special thing about the Clever Cracker Fragrance Factory,
Yeah.
C squared F squared, Clever Cracker, if you think about it.
That's wonderful.
So, the special thing about us is we're not all about the fragrance,
Oh,
are
no, we add more things. It's not just about the smell for our perfumes.
You need to be able to see it real good.
Yeah, so we add loads of dyes, don't we?
We do, and then everyone dies.
Yeah. That's bad, but it's good at the same time.
So we want to make a dye, okay? That's what we want to do. That's a special thing about our fragrance, because this doesn't smell whatsoever. Don't worry about the smell.
No, just ignore the smelly thing. This is just
benzene.
Yeah, we just invented a fragrance shop. So we're going to make this into an azo dye. It requires 2 steps.
It does. It sort of has an intermediate.
Mm-hmm.
So firstly, what do we need to add to this? Because we're going to keep going in this route. We're going to keep going.
We
adding to this.
We're going to make an intermediate step.
We are. And we're going to be adding NO2.
That sounds fun.
Does sound alright, doesn't it?
Yeah. And we're going to do it in a really cold place.
Yeah, sort of in your fridge, assuming it's turned on.
Yeah, less than 10 degrees is what you need to do it at.
So you could just say less than 10 degrees, or you could say something that was less than 10 degrees. I'd probably say temperature less than 10 degrees.
Yeah, that works well. So what does that do, Wayne? You describe it and I'll do things.
We're also adding HCl.
Oh, you're right, we are.
Yeah. And it's also, another thing people often admit, alkaline. No, it's not alkaline. My bad, I'm talking rubbish.
He's ahead of himself.
I am ahead of myself.
Later, people do forget.
Yep.
Maybe they forget because they remember to do it in the wrong place.
Yeah,
Don't
they
they?
do.
Maybe.
It's possible. So,
what that does, what does it do, Wayne?
well, we've got this here, basically, this nitrogen. Nitrogen can form 3 bonds. And it replaces the hydrogen, but forms a triple bond with it. It doesn't form a quadruple bond.
That's not. I was thinking that wasn't very clear. It actually was a plus, but I got a bit too excited. Yeah.
So because it's formed a triple bond with another nitrogen, and it can only form 3, and there's a bond here anyway, it's now a plus.
Yeah, and this is called benzene diazonium ion, is it?
Yep, a benzene diazonium ion.
Yeah. If you were to do it with HCl, like we have here, there may be a Cl minus bonded here,
Which is a benzene diazonium chloride.
Yeah.
So don't draw a covalent bond between them, they're ions.
They are ions, and if it asks to draw the benzene diazonium ion...
Yeah, if it doesn't say chloride, leave off the chlorine.
Yeah, because you get marks off for that.
As a general rule of thumb, you don't need the chlorine, it often says omit. You only put the chlorine really if it definitely says benzodiazonium chloride, in which case you need chlorine.
Yeah, so that's not an azodi.
It's not, but that's only the intermediate.
It is. So now we're going to have our alkaline conditions.
Don't put it too early.
No, that's silly. So you need alkaline conditions, and we also need phenol.
We do. Phenol. That's good.
I like phenol.
We know what phenol looks like.
We do know what phenol looks like. So we add these two things together, they'll be lovely, aren't they?
Yep, so we're going to have this benzene part, this isn't going to change, but where this is N triple bonded to N, we're just going to omit the chlorine, that's going to be gone. It's now going to be a stable double bond to the N, rather than a triple bond with a plus. So this has now formed 3 bonds, this forms a 3rd bond to phenol. So we make this, that's a phenol.
That is a phenol, it will be a phenol, it's not a phenol yet.
The OH is on the opposite side to the nitrogens, to the rest of the stuff. So if this is 1, then this is bonding on the 4th carbon.
Yeah.
That is actually a marking point, don't draw it off on tangents or anything.
Yeah, it has to be there.
And this is an azodie.
This is an azodie, so our perfumes will be really, really colourful, won't they?
Yeah, they will be. I mean, they probably won't be, it's completely unrelated, we're just really bragging about a fragrance.
Yeah, it's going to be great. I can't tell what that would smell like, it's bored.
It just smells of board pens to me.
Yeah, okay. But what if we don't have benzene, mate?
Yeah, so let's not start with benzene. For some reason we have a shed full of phenol as well.
That's quite a lot of phenol. I mean, I normally measure stuff in moles, but shed loads is more fun.
Yeah, well, it depends on the size of the shed, I guess.
It does.
But 1 shed full.
Okay, so we've got some phenol. We could do less stuff with it. I prefer benzene. I think it's
Benzene is much more
It's got a better name.
But the phenol reactions are somewhat easier, I guess.
They are, and is more reactive. So when we throw halogens at it, that's how you react, you just throw stuff.
Yeah, you just throw it,
Yeah.
Not at your teacher, don't.
And that's really
Or
dangerous.
we don't condone it if you do it, don't blame us.
That's not us. But wear safety goggles and everything will be fine.
Yeah, everything's fine.
Yeah.
So you add Cl2, say, we could add bromine, we could add iodine, whatever.
And what does it do?
And it creates a scary looking spider thing.
I love scary looking spider things. No wait, that's not right. I do not like scary looking spider things.
So it attaches either side of the OH, it attaches one of them, and opposite the OH, like that, to make a scary looking spider thing. Now, these Cl, the Cl2 is a Cl to a Cl.
It is.
And one of the Cl bonds to each thing.
But then it displaces a hydrogen, because it's a substitution, not addition.
And that hydrogen then reacts with the Cl that's left to make HCl.
It's done it 3 times.
It's done it 1, 2, 3 times. I can count to 3.
That's amazing.
So to balance it, we need this. 3 HCl and 3 chlorines.
So, we can do that.
Yep.
Don't know why you do that though.
Don't know why you do that.
No.
For no reason at all, we could also add sodium hydroxide.
Oh, I love doing things for no reason at all, especially adding sodium hydroxide.
Now, this is quite jazzy. Again, you've got to be careful of your ionic and covalent bonds here.
So what it does, it replaces the hydrogen we have up here with our Na, forming an ionic bond between the O, so there's the O minus and the Na plus. But we've displaced an H again.
Displaced that H, and we've still got an OH bobbing about.
So, surprise, surprise, we make a bit of water. So if you're really thirsty, and you've got loads of phenol and loads of sodium hydroxide, sorted.
Yeah, you can just make this, just react them together, just throw them at each other.
Yeah, that's how.
Alternatively, sell it and buy a good house.
And taps.
Taps with it.
Yeah, okay. We can also just add sodium for no reason at all.
No reason at all, we can just add sodium. Yeah.
So if we do that, it's similar. It makes the same first products we did before, the O, the Na, O minus and Na plus.
Yeah, so it still makes this, but now it's replaced one hydrogen step.
Yeah, and we've got no OH, we can't make water.
And it's going to form hydrogen.
It is. So we're going to have H2, but we're not. because there's only one of them. But like you're writing half H2 because just writing the H is not right.
Yep, so there's only one there.
You could
Alternatively,
double everything up, yeah.
yep, so this would be 1, then there'd be 2 lots of everything else.
And that's fine, as long as it's in the right ratio, sure, we're good.
Yep. You could, quadruple it up if you wanted to, it will accept it.
Yeah,
Don't know why you would.
But then why you do that in the first place, so whatever makes you happy.
Yeah, if you want to make hydrogen, I guess, a squeaky pop test, it's a really weird way to go about it.
Yeah.
So, this is a revision of stuff with things, really.
Yeah. And now we've done that, we don't have to go, we can just tell them, can't we?
Yeah, we can, yes.
Or just send them a link. That's faster.
That's way better, we
Yeah.
can do that.
Alright.
Speaking of planning the fragrance factory,
Yeah.
here comes our administrator, Zine.
Oh yes.
Hi Zine.
So you've got no money?